All right, let's finish off rivers, and we're going to focus on water issues in the West, and especially our western states, because they're so dependent on water coming in from other areas in order to survive and thrive. And so the main source of water in the southwestern United States really is the Colorado River. And so early on, as these states were growing, they recognized that they needed to treat that as a resource and to make sure that it was shared somewhat equally. And so in 1922, they did what was called the Colorado River Compact, and they split up the water into, based on 15 million acre feet. An acre foot is, if you have an acre of land and it has 1 foot of water on it, that's an acre foot. And so they estimated it 15 million acre feet, and then they split it up based on that. And the problem, though, is that was based when they had a wet period right before 1922. So it wasn't correct. And it after that, it kind of dropped down to about 12.5 million acre feet per year. And then even recently, it's gone below 12.5 million acre feet per year. So we're seeing a decrease in water coming from the Colorado River. However, we're still basing our allocations based on that 15 million acre feet. And so now we're seeing competition for the water, and I'll get to this in a little bit, and how we're going to reallocate it and decide how to use that resource. And we're going through, obviously, this climate change. And so we're seeing changing circulation patterns, and we're seeing increased evaporation. And then even when we had this year, you get variations from year to year. 2023 may have been the warmest in recent years on record. But this spring, we had this obscenely hot March for the continental United States. It's the hottest March on record for the United States. And that really affected snowmelt in the western United States. And that's what we depend on to store water that we receive in the wintertime to slowly release it into the rivers and reservoirs. Well, that hot March melted most of that. And I'll get to that in a minute. Sorry about that little video hiccup there. Anyway, as we move into what we're seeing in the western United States now, after wintertime, you can see that we're still in some areas an exceptional drought, but a drought almost throughout the entire western United States. That is kind of our forecast as we're moving forward. And this is, especially as we look at this area right in through here, this is where the Colorado River gets its water from. And if this is where we've got exceptional drought, that is obviously where we're going to see reduced flow downriver. Our lake levels are relatively close to what they were last fall, but we can see that even the river is down to 2/3 of its normal flow, and then it's actually still decreasing as we start moving in towards late spring and early summer. And this is just, it's an ongoing every year. We keep having to look at it, and we're trying to figure out how we can reallocate some of that water, minimize some of its agricultural uses, looking at requirements for new developments that they have to have water sources before they can be built out. All sorts of things are changing in the West, and it's not just in California. Arizona is being hit especially hard on some of this. This goes back 10 years, and this is something that was predicted primarily out of UCLA. A guy named Glenn McDonald talking about how our conditions were changing so that we'd see less and less rain throughout the western United States, and that's exactly what's been happening. Hot and dry for decades. Get used to it. So Powell levels are down. That's the lake, the first major lake that the Colorado feeds into in southeastern Utah, and then Mead, or this is Lake Mead is the one that's near Las Vegas, and I couldn't find a 2021 showing how the lake levels dropped. But it's still pretty dramatic between 1985 and 2010. We look at really around 2002, 2003, we kind of had the last peak levels of Mead in Arizona. And so these are the water intake towers for the dam and the hydroelectric plant. And you can see even in 2005 that the bathtub ring, that's the high water mark that you see over here, that is below that. And it just keeps getting lower and lower, and then even lower. And we had a wet winter in 24, so it came up just a tiny bit, but it's still well below where it should be. In 2026, we're seeing a continued drop in the Mead water levels. So this diagram is from November 2022, and you can see what the water level was then. We're up just a smidgen from them, but this was November of 2022 when it goes through the summer drought, and it's typically low after the summer. And then what you would expect to have happen over the wintertime is a lot of water comes into the lake, and that's not what happened. And so by the time we got to this summer of 2026, it's still pretty low. You'll hear different terms when they refer to the dam as far as dead pool, power pool. What that's referring to is that you have to have a certain depth of water to drive the turbines in the power plant, because that's water pressure pushing the water through the turbines. If it's too low, there's not enough water pressure, turbines can't turn. Think about that. This is a source of power for Las Vegas, Phoenix, and to some extent the Western power grid that would affect us as well. Now, dead pool is that you get a level where there's not enough water really to feed out of the dam itself, and so you end up with zero water flowing below the dam itself. There's various people talking about 2028 where we may reach dead pool, but that's kind of an extreme view. I personally don't think we're going to get that, but I wouldn't be surprised if we hit power pool by the end of 2028 at this rate. It's every now and then you get a wet winter, but we're still seeing that really steady decline over time. I mentioned this in the previous slide, same thing. We should have been dozens of feet above our November level because we should have replenished with the winter rains, and we didn't. We only got about 2 feet, and so the estimates are even more dramatic for 2026 versus 2025 for our mead water levels. Powell is even in a worse boat. They dropped over the winter time. They should be at least 30 to 40 feet above their winter, or the last summer, based on winter rains, and they're below. Instead of 30 feet above, they're a few feet below. That's not looking good. Powell ends up feeding into mead. So in 2020, that was that dip we saw before. Really, we're kind of in a similar boat, and it's not just us in the West. One of the Carolinas just declared a water emergency in that area because of the drought they're experiencing. But we're focusing on the West. So us, California, in the spring, we're starting out in an abnormally dry period. This isn't great. Most of our water in California comes from either the rain that falls in the Sierra Nevadas, or what comes from the Colorado River that you saw in the previous slide. What happens is that winter rain and then the winter rain and snow is what refills our lakes. So it's not unusual to see our lakes full in the springtime, and we've had enough water coming and snow coming last few years that our reservoirs have been up at good levels. But right now we're close to average rainfall, which you'd think, well, that's good, that our Northern California areas are getting average rainfall. Well, precipitation that fell in January, February was snow, and then that would be stored and then slowly melt and refill our reservoirs. Well, it all melted already because we're at like 10% of snowpack, and so even though we're close to average precipitation, it fell in the wrong way and melted. So it fell as snow and then melted. So a lot of this rain that we got, we've already lost. So if we look at our reservoirs, they look good. But again, this is normal, and as we use the water, it would be refilled by the snow melting. Well, now there's nothing to refill it because the snow melt has been so extreme. So the snowpack, this blue line is where we are this year. This gray line is average. And so we're at 10%, 12% of average. That's staggeringly different, and this is where we're going to see problems throughout the year. Now, the drought has been so pervasive over the last few decades, really, that we're starting to see kind of wholesale change in vegetation where they can and can't survive. So oak trees, which, by the way, are really, really hard to kill. Once they get established, they're kind of designed to survive an occasional drought, but not a continued drought. So these dead oak trees are indicative of climate change. And so this is, you guys all remember your CSB climates. We talked about oak woodlands. This is no longer an oak woodland because it doesn't get enough water occasionally to survive this extended drought period. This is off the I-5 as you're going down towards the Grapevine. We're seeing a problem in our forests throughout California that this extended drought is starting to kill off a lot of trees. And so we're seeing in some areas upward a third of the forest is dead. And of course, dead trees burn very, very easily. So that's another problem that's caused by this extended drought in the West. Which kind of leads us to, should we be conserving water? Maybe. What's the we? Well, we as individuals, we're not the problem. We're actually really good at conserving water because we've been doing it for a long time. Those low-flow faucets, the low-flow toilets, everybody nagging you about not washing your car during the heat of the day. All of the recycled water that we're using for irrigation for our homes and subdivisions. We're doing good as individuals. Where we're using too much water is in agricultural uses. And so we grow alfalfa, rice, and cotton, which are all high water growers. In fact, rice grows in water, and so you have to have a kind of a constant flow for water. So we've been subsidizing farmers for so long that really we've created an agricultural industry that economically is dependent on cheap and abundant water, which we no longer have. It really wasn't until about 15 years ago when we had a drought in 2008, 2009, where we finally started to see restrictions. And so this is really far into it. And so the restrictions were on what water they would get from the state, not what water they can pull from the ground, what water they would get from the state and other, statewide water agencies. Kind of fought off a lot initially, but we're finally starting to see kind of a shift in mentality of what we should and shouldn't be growing to some extent. So cotton and rice production has dropped a little bit. Alfalfa has dropped a little bit as far as the percentage of what we're growing, but it's still not where it needs to be if we're going to have water available for other uses. So every type of crop has a different amount of water that it uses, and one of the things we're seeing in the Central Valley is that a lot of our grape production is shifting into almonds, which uses significantly more water. And then some of these things that we grow in the Central Valley really, really suck up a lot of water. Walnuts especially, it's always staggering to see how much water a walnut grove uses. So that's why we should be drinking more wine, for those of you over 21. So we see this in the Central Valley, and the irony is that these are walnut trees in the background, which are high water user, and so this is why they're arguing that the state and those local agencies, this is a farmer put up the sign, wants more water for their agricultural output. And it's kind of a question of, well, what should we be growing? Can we regulate what we grow in California? And the farmers are doing it to themselves. This was a few years ago, this was a grape orchard and vineyard, sorry. And they tore out all those trees to put in, I'm not sure if this was almonds or walnuts. Either way, it's a significantly higher water usage. Like, well, how can the farmer do that? See this little thing over here? They're now pumping out of the groundwater table, so they're not dependent on a agency for water. They're getting their own water. And so throughout the Central Valley, you're seeing farms with these pumping stations pumping out groundwater for use on their farm. Groundwater is limited as well. It's replenished by rainwater every year. We're starting to see that being drawn down, and it's every year they're having to drill deeper and deeper to tap into where that groundwater is. And when you do that, that water actually kind of supports the surface, and so the more water you take out, the less that surface is supported. So there's areas within the Central Valley of California that have sunk, and this one says 28 feet. It's actually been upgraded in some areas to over 30 feet. That affects rail lines. It affects how canals flow. So if you drive through the Central Valley, if you're on 99 or 5, you're not really going to notice it. You have to be in that stretch between it to see some of the construction that's going on rail lines and canals. When I'm talking about canals, this is an earthen canal. It shouldn't be within a foot of the brim. So this area has subsided so much, well, water flows downhill, right? And so this area has subsided so much, it's getting more canal water flow into it than normal. And this subtle things like this, well, what if the opposite was true? Is that the source of the water in the canal sinks, it's not going to want to flow uphill to go to other areas. So you see some canals that are overly full, and you see some canals are dry because their source area for the water has sunk. This is crucial to agriculture, and so this is why we're starting to see, instead of depending on canals, more and more of those pumping stations taking place. So Again, go ahead and brush your teeth, leave the water running, flush the toilet twice. You're going to be fine. It's the agricultural areas and commercial uses that are the problem. So again, we're seeing more state crackdown. All right, that's it. That's your update, and we'll see you on the next topic.